Assalamu alaikum. We know when an object moves in a circular path, we call the motion of the object as circular motion. This circular motion is classified into two as uniform circular motion and non-uniform circular motion. Already in my previous video, I have explained about these two things. In this video, we will discuss about non-uniform circular motion in detail. For that, I consider a circular path in which an object is found to be moving in an anti-clockwise direction, that is in this direction. It's found to be moving in this direction. If it is so, then the tangent drawn to this circular path, what is this tangent? The tangent is nothing but a line which goes touching a curve or a circle. Clear? So this line is a tangent. It provides us the velocity vector or the velocity with which this object is moving in circular path. So here, to show you that this tangent which represents the velocity is perpendicular to the radius, I draw a line which connects the center of this circle, which is represented by letter O, to this object. Okay. Now if you look at this carefully, you will find that the angle between the radius and this tangent is 90 degree. It is 90 degree. They are perpendicular to each other. Okay. And as I told you, this represents a velocity vector. If the acceleration acts along the tangent, then we call such acceleration as tangential acceleration. Now this also we have learned earlier. Got it? Now before I tell you about non-uniform circular motion, let me tell you what is circular motion, uniform circular motion. If the magnitude, when you talk about vector is, so when you talk about velocity is a vector quantity. It has got both magnitude and the direction. If the magnitude of the velocity vector remains same throughout the motion of the object in circular path, and only the direction changes, means we call such circular motion as uniform circular motion. In uniform circular motion, only direction changes, but the magnitude remains same throughout the motion. Clear? But when we talk about non-uniform circular motion, here velocity, which has got both magnitude and direction. Here both the magnitude and direction vary or changes with time. Varies with time. Here the meaning of varies, changes. Now if both the things change with time, then the object is said to be in non-uniform circular motion. In such case, the object will not move in one particular circle. Now, if the velocity increases, if the magnitude of the velocity increases, means it will move away from the center. If it gets slower, if the magnitude reduces, means it will come close to the center. This kind of thing will happen. So in such case, it can either move in this kind of spiral path when the velocity reduces. In such case, the object will start getting closer to this center. Clear? Here, this shows the movement of the object when the velocity increases. Remember this. Got it? So we call such kind of motion as a non-uniform circular motion. Clear? Now, here I have represented the tangential acceleration. There is one more acceleration called as centripetal acceleration in circular motion. This centripetal acceleration acts towards the center. Remember that. Centripetal acceleration, which is the represented letter AC, always act towards the center. Clear? So here we have got two kind of acceleration. One is a tangential acceleration, which acts along the velocity, and another one is a centripetal acceleration, which acts towards the center along the direction of along the radius. Clear? Fine. So because of the presence of these two accelerations, both are vector quantities. Their resultant act. How to get the resultant of these two vector quantities, that is AT and AC, that can be obtained with the help of parallelogram law of vectors. Okay, what is that? Let me show you. Here, just draw a line which is parallel to this. And I do the same thing with this line as well. I draw another line which is parallel to this. So it forms a parallelogram or a rectangle. Okay. Now, the tangent drawn here. This is the tangent. This is the diagonal. This diagonal divides the rectangle into two equilateral triangles. It divides this rectangle into two right angled triangles. Okay. So here this is one vector, which is nothing but AT vector. This is another vector, that is AC vector, centripetal acceleration. This is tangential acceleration. These two are represented by the sides of this right angled triangle. Okay. Now here the angle made by this diagonal and this adjacent side is taken as theta. Now, which gives us the direction of this resultant vector, which I represent using letter AR vector. Okay. So I told you here I am going to use the parallelogram law of vector. Actually, I am not using parallelogram law of vector. I use the triangle law of vectors. Okay. To get the resultant vector. Now let's apply that. I take this right angled triangle here. Okay. Fine, dear. Let's go ahead. Here is theta, and what is the value here? That is AT vector, and this is the AR vector, and this is the AC vector. Okay. Now, according to trigonometry or according to geometry, this side is called as opposite side. This is the adjacent side, and this is the hypotenuse of this right angled triangle. Okay. Now, by keeping this in mind, see here I take I apply triangle law of vector. Triangle law of vectors. So what I'll get if I use the triangle law of vector, I'll get the resultant vector, that is AR vector, and is found to be root of the square of remaining sides. Okay, here square of a tangential acceleration plus square of centripetal acceleration. Fine, this is what I have taken. Okay, now here what is the value of AC vector? That is centripetal acceleration. Here centripetal acceleration is nothing but minus v square upon r. This we have obtained in the previous video. Okay, so this I am going to substitute here. This is the equation number 1. I take this as equation number 2. Now 2 is substituted in a 1. Clear? What happens if I do so? Yeah, r vector is the root of a t square plus minus of v square upon r the whole square. This is what I get. Now when I square this, what I get? This minus sign will disappear. Minus into minus will become plus. So I get this. T square plus v square upon r the whole square. Correct? This is what happened. This represents the magnitude of a resultant vector. What is that? CR vector. So I told you this is the magnitude. So you have to mention vector symbol here. Okay, only represent the size. Okay, this should not be mentioned here. Now I will give the direction of this resultant vector. Direction of a vector. How to get that? It's too simple. It can be obtained from this triangle. Tan theta. Take a tangent of this angle theta. What is that? Opposite side divided by adjacent side. Adjacent side. Okay, what is the opposite here? This is the opposite. Represent letter A T. Okay, and the adjacent side is letter A C. Clear? So this is what we obtained. Now from this theta value is found to be tan inverse of AT upon AC. So this is the final expression which provides us the direction of the resultant vector. If two vectors, namely centripetal acceleration and tangential acceleration, act this manner, means the resultant will act along this diagonal. Okay, this is what we understand from this diagram. So as I told you earlier, in non-uniform circular motion, along with the magnitude, the direction changes in all kind of a circular motion, but along with the direction, magnitude also changes in case of a non-uniform circular motion. I hope the video is useful. If you have any kind of doubt related to the topic, can you put a question in the comment section? Thanks for watching.